Now, many investigators have nonlinear isotopic effects when we change the content of deuterium near the small concentrations. And on this evidence, the principal question appears: what is the reason of this effect? Just now we have also the resonance hypothesis, but this is some kind of a result again. And we try to ensure that the physical chemical properties of mixtures of water with any amount of deuterium is linear. Other words, the water solution, I can say, are ideal. From the literature, it is known that high concentrations of water looks like ideal, really, and have very small deviation from this law. And nevertheless, we have, as I know, two publications which show that that deuterium-depleted water have some anomaly properties which are unpredictable. So we repeat some of them. I show that viscosity. Maybe I shall take my one. This is literature data for ordinary and heavy water, and you can see that this difference is the greatest one in comparison with the other. We used light water, of production of Anton Chernopyatka. He is sitting here, and it is characterized as for deuterium 4 ppm, oxygen 18, and oxygen 17. So this is was technically possible. We use also glass capillary viscometer, and the accuracy, we find maybe the best one is 0.5%. And we have no difference between ordinary water and distilled water at this concentration of ppm. So next one. Why it can happen? I think I don't know the answer really, because there was announced a great difference between ppm water and distilled water. We have very long prolonged measurements, and this is the worst maybe. We can see some unexpected jumps when measuring viscosity in capillary viscometer. But if we repeat several times, we can get to the constant line, and there is no deviation between three portions of water: deionized water, 4 ppm water, and distilled water. So I want to argue to the second publication of Goncharuk and the others from Ukraine. You can see here a very high accuracy of these measurements. I think it is not possible. It is absolutely equal in all the measurements that it is absolutely impossible. And moreover, you can see that the isotopic effects became normally. Isotopic effects increase with decreasing temperature. This is the general thermodynamic properties. But here we can see inverse position. So this is, I think, this is not true. Here I talk about kinematic viscosity. You have seen here a very large deviation that I think it is not so. We check also the boiling point and melting point. The boiling point was equal with the accuracy of 1 degree. You can see here even 5 degrees difference. And the melting point was equal to with the accuracy of 1/2 degree. Very strange is this result. The transverse relaxation NMR time, 3 times approximately less in light water, and we measure it and we can't see such great effect. So this is, I think, also not good. This is the, and we have, this work was done much earlier because we're interested in the nonlinear effects at small increasing of deuterium content. And we measure heat capacity, and we have no some deviation from the linear dependence in the range of 0.5 to 1%. And the last one that we have measured with a very sensitive method of measurements of ultrasound velocity with the accuracy of such type in the range of deuterium from 4 to normal water, and temperatures, 3 temperatures from 10 degree to 30 degree. The obtained plot is absolutely linear, and you can see here the results. So really, really you can see that the deviation is very small, maybe the last number. And no, this is the table data, so there is no error here. These all the numbers were tabulated from the data from textbooks, and this was the cause of the great sensitivity was maybe explained by the differential method. So we have some state, and we have measurements for 4 ppm, 70 ppm. It is linear dependence, and according to the temperature, 10 degree, 20 degree, and 30 degree. And the accuracy of temperature was also very high. So this is also linear dependence. As a conclusion, we want to say that we have no evident basis for the cause of thermodynamic properties of water in biological effects. Thank you.
Thank you.